Доброе утро.
Good morning. Hopefully you believe it is still good morning. We will start our morning session and we'll start it from Anton Makarov. Fine. Good morning. My name is Anton Makarov, Gate Flow Company. I will brief you about the software-defined networking. I saw that during our previous conferences of ENOG, SDN was detailed, and therefore immediately I will note that I will not tell you about Telco Cloud, how it shall be built. I will tell you how SDN shall not be built and constructed. Firstly, many people from telecom operators make a mistake thinking that SDN is a service edge data centers and only there it shall exist, providing those benefits and advantages it can provide at the data center. But in our case, we consider the transport SDN the method to save the band in the transport network, where you have very costly bit plays an important role. This is a totally different idea and approach, but nonetheless, particularly in the context when we discuss what is to be done with the traffic that can emerge in IoT, when there are specific categories of subscribers, such as traders, gamers, for whom it's important the extra milliseconds of delay are very critical and vital. And from our experience, I can tell you what you shall not do in this particular case. This is our input. Firstly, SDN shall be cheap, since we all want to cut costs, specifically when the telecommunication is not extra beneficial and profitable, when the task is to save CAPEX, OPEX, and this is very relevant. Like many colleagues say that SDN, it is not about something cheap, but we believe that it is critically for being cheap, for making something extremely cheap. This is the first point. Secondly, the saving of OPEX because of the centralized management and the transfer from the resource type services or resource-based services. Many marketing words and terms about SDN. I will not repeat them. My colleagues asked me to be within the agenda time. And the first mistake which is made by all those that try to deploy SDN in transport networks is poor understanding of the number of abstractions, how the SDN shall look like. Generally, it is pictured as including 3 parts. So SDN controller, applications, and OpenFlow agent. But due to some reason, quite frequently, there is such a mistake or misunderstanding that SDN controller and the applications that live there, they will do everything instead of you. But the situation is much worse, as those applications that ensure the major telecommunication services, they have to follow the rules of business logic, subject to the condition that the network is legacy network is quite flat, and it's quite difficult to reach this. And therefore, you need to understand, first of all, at which level of abstraction which components will exist, and secondly, how they will be compliant with the needs of the businesses of any telecom operator. A similar mistake is made in terms of the SDN controller. It is viewed as a nice engine that will control and manage some elements, and people forget about those troubles it can cause. First of all, it is viewed as a normal server with all the consequences it has. So it can be hacked, attacked, and it is built on a relatively weak processes, and its capacity cannot be enough to proceed with some tasks. And the most unpleasant thing is that SDN controller is one rejection point for every network, for the whole network. If you try to build your network on one controller, then this rejection will make your network a failure, and this is the major risk. Apart from that, there is another thing. The operators have their own legacy networks. They have invested capital in it, and the question is what to do with the equipment which is not supported, which does not support some great protocols. You must swap it or lose your investments, or you can use it for some other purposes. That is the task which is to be resolved. The next level, Open Networking Foundation, we have the universal level of abstraction, that is Open Flow Protocol, which is quite a theoretical model of abstraction, which is not supported fully by no device, and the use of it, like it is described in the specification of the protocol, is not very reasonable and feasible, I believe. And we shall be judged from the fact of the real capacity of the network elements, which can be called commutators or routers. It doesn't matter, any network elements which you would like to connect to it. They have some device limitations, hardware limitations, and these limitations generally are subject to the way of construction of byply processes and generally in the normal legacy network. And the building of this network from the transport network, you shall understand the structure, how these boxes are built and how they operate. The most standard boxes which can be used for the cheap networks, they have the substantial limitations. OpenFlow offers to use for the recording of the rules and the fulfilling of the rules of traffic forwarding, the TCAM pallets or panels. It is quite cheap. This is a very expensive resource, by the way, and it is used not properly, but SDN believes that the traffic will be very nice and engineering will be great, but OpenFlow to some extent broke this general networking and offers to run traffic over the headings of all the headings. You shall not do that, because from our experience we see that forwarding traffic in SDN shall not be similar to legacy networking. If you want routing, so you shall not mix everything up. The real device cannot mix everything up. It's important to remember this. What else? Which are the disadvantages in the traditional approaches to the building of SDN, any SDN, by the way? Generally, normal programmers start to do that are used to having very specific programming languages. They have unlimited resources, and the whole approach to the building is top-down, starting from the top and then to the lower levels, at the level of controller network elements, at which the forwarding of traffic is actually affected. As I said, you shall start from the bottom, and the whole model shall be broken down, because the application, as I said, shall be precisely reflect the business logic of your operations. If they are B2C services or some B2B services in the master network, generally it is not done in this network because it is already available. Generally, we are talking about the parameters of the networks and the access networks. And accordingly, if you use the standard MIF services for B2B and B2C, meaning that these applications shall implement these services. You shall not wait for some other sets of universal applications, nice drafts that will resolve all your problems and troubles. It is a must to pay attention to SDN, and it shall not be viewed as a legacy network. And roughly speaking, you should not enter the console and dashboard and configure anything. This is a totally wrong approach. Through this approach, you will break the SDN. The approach shall be quite traditional one, which includes 3 environments. I do apologize for my coughing. There shall be the environment of development, of testing, and of productive use. And if in the environment of development you can use many things, in the test environment you can just check, examine whether the code is correct, whether it is functional. But in the productive operations or production, it shall be affected automatically by means of descriptors. SDN controller. This is a component which in the nature exists in many forms, but none of them is universal. Firstly, because of the fact that they have uncertain interface of controller. It is not standard and it is not specified duly. On the one hand, the interface is through which the applications shall communicate the controller. On the other hand, because of a large multitude of services offered, this interface shall not be rigidly fixed. And generally, RST-PIN is used, but general options are possible. RSTP is not the best option, by the way. In terms of the network elements themselves, firstly, SDN and OpenFlow are not the equal things. OpenFlow can be used, as I said, with very large limitations. Today there are a lot of other elements, and for transport network, I believe they would be much more preferred. The use of the application, or the use, like many like to do it, for forwarding parimark addresses of sources and the recipient, you can use it, but only by the use of the specific commutators. They are very expensive, and I'm not sure that they will fit your transport network. There is an option of the use of the devices based on NPU, a network processing unit. A good option, by the way. On the one hand, it is quite flexible. On the one hand, some vendors provided some network devices for them that fully support the specification of the open flow, but you must remember that this is a software element, and they distribute the processing of network packages, but nonetheless these devices are again subject to some other attacks like any normal server. And the last option is software-based switches, which are proposed for open cloud. And here the question is the price. They are very expensive and too slow. Too slow, not from the point of the band they can process, but they cause a lot of delays, and I believe it is not quite nice to face such a situation in transport network, because some groups of subscribers, to my information, to at least what I see, gamers, for example, they buy the wireless mouse that enables them to save up 1 millisecond, but this way we will cause a few millisecond delayed because of the use of this technology. For the comparison, rough estimations of the productivity and the cost of different network elements, device-based elements, depending on the technology they apply. The traditional switch ICs, generally, they are about $1.5 per gigabit per second. And you can go upper to NPU and CPU, and you see that the difference is tremendous. This is a list of what I have shared with you, but this slide is just to wrap up, to sum up what I have already shared with you. That is all I wanted to say. Thank you very much for your attention. Do you have questions to address our speaker, Anton? No? Then, thank you.